Heidi-ho, Renaissanceteers, and welcome to Renaissance Puzzle number 189, Tackling the Tetrahedron. A tetrahedron is a three-dimensional figure with four triangular faces. 1, 2, 3, 4. The word tetrahedron means four faces in Greek. Because it has a triangular base, a tetrahedron is also called a triangular pyramid. The Great Pyramids of Egypt have a square base like this, and four triangular sides. When architects talk about pyramids, they usually mean this form. But for a mathematician, a pyramid can have a base of 3, 4, 5, or more sides. A tetrahedron has 6 edges, and for this puzzle, all 6 edges have a length of 1. The object of the puzzle is to determine the height of the tetrahedron. To figure out the height, it is necessary to know some of the properties of triangles. In the interest of making this puzzle educational, I would like to present a tiny triangle tutorial to prepare you to tackle the tetrahedron. So here we go.
Here we have a square formed with 4 toothpicks joined together with hot melt glue. And hot melt glue is rubbery, so I can flex these joints very easily. And you can see that the square is not a very rigid structure. Let's look at a triangle. Here's a triangle likewise formed from hot melt glue and toothpicks. And I can press on this, and you can see I'm pressing pretty hard. I'm flexing the toothpicks, and it does not want to deform. This is the property of triangles that makes them so interesting. They have their own branch of mathematics called trigonometry, which means triangle measurement. Now let's take a look at a three-dimensional figure formed from squares. This is a cube, and the cube, likewise, the square, is very flexible. It's not at all a rigid structure, so we can't really tell anything about the volume of this figure just knowing the length of its sides. On the other hand, if we take a figure formed with triangles, this is called a tetrahedron, which means four-sided. This figure is also, like the triangle, very rigid. You can see I can press on this and flex the toothpicks, and it does not want to deform.
Because of their rigid property, triangular braces are used in square steel frame buildings to prevent them from collapsing. Let's take a look at the different types of triangles. A triangle with 3 equal length sides is called an equilateral triangle. The word equilateral comes from Latin equilateris, which just means equal-sided. An equilateral triangle also has 3 equal angles. A triangle with just 2 equal length sides is called isosceles. It also has 2 equal angles. The word isosceles comes from Greek isos, meaning equal, plus scalos, leg. And with a little imagination, it is easy to see it as having 2 equal legs. Triangles that have 3 different length sides are called scalene. They also have 3 different angles. The word scalene comes from the Greek scalenos, meaning unequal. So if you are bewildered by trigonometry, and it all seems like Greek to you, then you are on the right track. And speaking of Greek, let's not forget our old friend Pythagoras and what he taught us about right triangles. An angle of 90 degrees is called a right angle and is often indicated by this symbol. A triangle that has a right angle is called a right triangle, and the side opposite the right angle is called the hypotenuse. For easy reference, let's label the hypotenuse H and the adjacent sides A and B. If we construct a square with sides of length h, it has an area of h squared. Likewise, if we construct squares with sides of length a and b, they have areas of a squared and b squared. In 500 BC, the Greek philosopher Pythagoras found that the area of the hypotenuse squared is equal to the sum of the squares of the two adjacent sides. This is called the Pythagorean theorem, and it may be the most frequently used theorem in mathematics. You should certainly become very familiar with it if you want to be proficient in math. It is also a tool that will help you find the height of the tetrahedron to solve this puzzle. By the way, do you recognize the shape that Pythagoras is holding? Another useful thing to know about triangles is that if you add up their three internal angles, they always sum up to 180 degrees, which is halfway around the circle. Here is a little video demonstration.
Here we have a triangle cut out of cardboard. It has three sides of different length, so therefore it is a scalene triangle, and likewise it has three angles of different values. I cut this using a shear without making any measurements, so there's nothing special about this triangle. Now let's take a scissors and cut these angles off. Like so. And if we reassemble them against this steel scale, we will find that they line up perfectly to form a 180 degree angle. This is the case with any triangle, scalene, equilateral, isosceles, right triangle. The angles always add up to exactly 180 degrees.
Let's take another look at the equilateral triangle and apply some of what we have just learned. We know by its symmetry that the three angles of the equilateral triangle are all the same. Let's call them A. And since we know that they add up to 180 degrees, we know that 3A equals 180, which means that A equals 60. And let's make the length of the triangle's sides be 1. Now let's draw a vertical line right down the middle of the triangle, dividing it into two right triangles. Notice that we have bisected the 60-degree angle at the peak into two 30-degree angles. And also notice that we have divided the base into two segments of length 1/2. Let's focus on the triangle on the right. We know that the side opposite the right angle is called the hypotenuse. And let's call the base B. We don't know the length of the vertical side yet, so let's call it A. Pythagoras taught us that a squared plus b squared equals h squared. Solving for a, we get a is equal to the square root of h squared minus b squared. Plugging in the known values for b and h gives us the square root of 1 squared minus 1/2 squared. This simplifies to the square root of 1 minus 1/4, which equals the square root of 3/4, which further simplifies to a is equal to the square root of 3 over 2. So let's tidy things up a bit. Because it has angles of 30, 60, and 90 degrees, this is commonly called the 30-60-90 triangle, and it is an important one to become familiar with, as it appears often in math exams like the SATs. Let's scale up the lengths of the sides to eliminate the factor of 1/2. These two triangles are of different sizes, therefore they are not identical, but they have the same angles, so they are said to be similar. That is, they have the same form. The big one is a scaled-up version of the small one. The big triangle is called either a 1-2 square root of 3 triangle or a 30-60-90 degree triangle interchangeably. The ratio of lengths is the same for both triangles. For example, the ratio of the hypotenuse to the side opposite the 30-degree angle is 2:1 for both triangles, and the ratio of the two adjacent sides to each other is square root of 3:1. This will be helpful in solving the puzzle, by the way. In closing, remember that it is your mission, should you accept it, to determine the height of a tetrahedron with all sides equal to 1. Note that the height A is the distance from the peak of the pyramid to the center of the triangular base. A right triangle is formed by A, B, and H. Find B first. Thus ends the tiny triangle tutorial. Now you are totally tutored to tackle the tetrahedron. And so without further alliteration, good luck and happy Renaissancing.